In this video, we're going to be writing parametric equations from points and time. So for our first question, we have write parametric equations that represent the following objects. We're first going to consider what x is. So if we plot our points tx on our tx plane, we have 2, 11, and we have 6, 5. So we want to find the slope between these 2 points. M of x, this is going to be 5 minus 11. 5 corresponds with 6, and then minus 2. This is negative 6 over 4, and that's negative 3 over 2. Now, after this, we're going to find the point slope form. Point slope form. And that means you use x minus 11 is equal to negative 3 over 2, t minus 2. You just distribute after this, and you get x minus 11 is equal to negative 3 over 2t plus 3. After this, you can add 11 to both sides, and you get x is equal to negative 3 over 2t plus 14. So after this, we have to find our equation for y. We can do the same thing and write our table. Ty with the corresponding points of 2, 6, negative 2, 10. So m of y, this is going to be 10 minus negative 2 divided by 6 minus 2, which is equal to 12 over 4, equal to 3. Now we're going to find the point slope form of this as well. Point slope form means we have to plug in a point. So we're going to have x, or no, here we're going to have y. So y minus negative 2 is equal to 3 t minus 2. That's your m. You have y plus 2 is equal to 3t minus 6 minus 2 minus 2. Y is equal to 3t minus 8. So that's your answer. And these are your two equations. So you have y of t is equal to 3t minus 8, and you have x of t is equal to negative 3 over 2t plus 14. Now we can check our work by checking t is equal to 2. So for x of 2, you have negative 3 over 2 times 2 plus 14, which is negative 3 plus 4, which is 11. Now for y of 2, you have 3 times 2 minus 8 is equal to 6 minus 8, and that's equal to negative 2. So when you plug in t of 2 into the two equations that we got 11, negative 2. Now what about when we have t is equal to 6? So you're going to have x of 6 is equal to negative 3 over 2 times 6 plus 14, and that's going to be negative 9 plus 14, which is equal to 5. Now, what about when you have y of 6? So y of 6, you're going to have 3 times 6 minus 8, which is 18 minus 8 equal to 10. So at t equals 6, you're going to have the point that is 5, 10. Now let's do another problem. Write the parametric equations that represent the following object. So you have negative 3, 7 at t1 and 9, negative 5 at t4. So we're going to use the tx points, and we're going to create a table. So for tx, you're going to have 1, negative 3, and you have 4, 9. So you're going to find the slope, which is mx is equal to 9 minus negative 3. That's divided by 4 minus 1, and that's going to be 12 divided by 3, which is equal to 4. Now you're going to use your point slope form again, like we did above. So that's going to be x minus your x coordinate, and we're going to use the point of negative 3, 1 to plug in. So that's going to be x minus 3, negative 3, is equal to 4t minus 1. So that is going to become x plus 3 is equal to distributing. You're going to have 4t minus 4. Now you're going to subtract 3, and you have x is equal to 4t minus 7. So your first equation is x of t is equal to 4t minus 7. Now we're going to find the equation for our y. So you're going to have t of y, ty, and you're going to have 1, 7, and you're going to have 4, negative 5. So my is equal to negative 5 minus 7 over 4 minus 1, and that's equal to negative 12 over 3, which is negative 4. Now you're going to use point slope form. Point slope form, you're going to have y minus 7 is equal to negative 4t minus 1. And if you distribute that, you have y minus 7 is equal to negative 4t plus 4, and you can add 7 to both sides. You are going to be left with y is equal to negative 4t plus 11. Now you have y of t is equal to negative 4t plus 11. So these are your two answers, and you can check these by seeing if we plug in a point for t, if we plug in a time for t, would we get that same xy that is spat out? So for example, if we did t is equal to 1, would we still get the coordinate point negative 3, 7 that corresponds here? Would we still get negative 3, 7 for t is equal to 1? So let's check t is equal to 1 with our two equations. So you're going to take your x of 1, and you're going to set that equal to 4 times 1 minus 7 is equal to negative 3. And you have y of 1 is equal to negative 4 times 1 plus 11 is equal to 7. And that gives you the point negative 3, 7, which matches with what we have originally that was given. Now we're going to check t is equal to 4. So when we had that t is equal to 4, we had the point 9, negative 5. Let's see if this matches. So for t is equal to 4, we are just going to plug in 4 for our t's. So you have x of 4 is equal to 4 times 4 minus 7, which is 16 minus 7 equal to 9. And you have y of 4 is equal to negative 4 times 4 plus 11 is equal to negative 16 plus 11 equal to negative 5. And that's going to give you the point 9, negative 5. So what about this? Write a parametric equation that represents the following point: 2, 1 at t is equal to 3, and 11, negative 11 at t is equal to something. So the object is going to move 5 units per second. And we're first going to start off with finding the missing time because we don't know what that time is. So what we're going to do is we're going to use the distance formula, and that is d is equal to the root of x2 minus x1 squared plus y2 minus y1 squared, and that's going to be d is equal to the root of 11 minus 2 squared plus negative 11 minus 1 squared. D is equal to the root of 9 squared plus negative 12 squared, and that's going to be equal to the root of 81 plus 144. So that's going to equal to the root of 225, and that is equal to 15. So that means that the object travels a distance of 15 units. Object travels. So now we're going to use speed to find time. So we are given that the object moves at 5 units per second, so that means that is your speed, and that's equal to 5 units per second. And we have the relationship that time is equal to distance divided by speed. So if our distance is equal to 15 and we are moving 5 units, that is going to be equal to 3. So it's going to take 3 seconds to go from your first point to your second point. And since the object is at 2, 1, so when you're at 2, 1, that is when you are at t is equal to 3. That means your second point, so if this is your first point, that's going to happen when you're at t is equal to 3 plus 3, which is 6. So you're going to be at 11, negative 11, at t is equal to 6. Now we need to find the equation for x. So we're going to use t of x. So now we have our 11, negative 11, and we have what our time is. So for t of x, we can start off by creating our table like we did earlier. You're going to have t here, and you're going to have x there. You're going to have 3, 2, and you're going to have 6, 11. So you have mx is equal to 11 minus 2 over 6 minus 3 is equal to 9 over 3 is equal to 3. Now you're going to use point slope. So you just add 2 to both sides. And x is equal to 3t minus 7. So that's going to be x of t is equal to 3t minus 7. Now, we need to find our equation for y. So we have our points t and y. We have 3, 1, and we have 6, negative 11. So my is equal to negative 11 minus 1 divided by 6 minus 3. That's equal to negative 12 over 3, and that's equal to negative 4. So you have y minus 1 is equal to negative 4, which is your t, negative 4, t minus 3, and you have y minus 1 distribute. That is going to be negative 4t plus 12, negative 4t plus 12, and plus 1 was equal to negative 4t plus 13. Now, these are our final answers. We can check this by checking when t is equal to 3. When t is equal to 3, our equation's x of t. So we have x of 3 is equal to 3 times 3 minus 7 is equal to 9 minus 7, which is equal to 2. So when you have y of 3, that's equal to negative 4 times 3 plus 13. That's equal to negative 12 plus 13, and that's equal to 1. And that successfully gives you 2, 1. Now check when t is equal to 6. That's when you have x of 6 is equal to 3 times 6 minus 7, which is equal to 18 minus 7 equal to 11. Now when you have y of 6, that is equal to negative 4 times 6 plus 13, which is negative 24 plus 13, which is equal to negative 11. So that's going to be 11, negative 11. So when you go from t is equal to 3 to t is equal to 6, that means your elapsed time is equal to 3 seconds. And because at 5 units per second, your total distance is going to be, when you have 5 times 3 equals to 15. And that is that matches the distance that we found too. So this also corroborates 15 units, 15. Now for our final question, write parametric equations that represent the following objects. So again, we're going to do something similar where we find the distance. We're going to take our x's and we're going to square that plus 13 minus negative 2 squared. And that's going to be 9 is equal to the root of 12 squared plus 15 squared. So you're going to have the square root of 144 plus 225. And d is equal to the root of 369. You can factor this because 369, you can factor with radicals, is 9 times 41. D is equal to the root of 9 times 41, which is equal to 3 times the root of 41. So your distance is equal to that. That is 41. Now you need to find what your time elapsed is. Your time elapsed. So you're going to use that time is equal to your distance over speed. And that is going to be 3 root 41 divided by 3. Root 41 divided by 3. That's equal to 41 because your 3's cancel out. So that's going to be 41 seconds. And since we know that your first point is t is equal to 2, that means your second point is equal to t plus t. No, t is equal to 2 plus the root of 41. So that's when your second point is going to happen. So you need to find what x is going to be. So right now what we have is, for tx, we have 2 negative 6, and we have 2 positive, no, we have here time of 2 plus the root of 41 minus 2. So mx is going to be equal to 12 over the root of 41. And we can rationalize this by multiplying the top and the bottom. So 41, 41. that is going to equal to, canceling that out, we have 12 root 41 over 41. We can use point slope form. So you have x minus negative 6 is equal to 12 over the root of 41. T minus 2, x plus 6 is equal to 12 over the root of 41. T minus 2, and you're just going to subtract 6 from both sides. You're going to have x is equal to 12 over the root of 41. T minus 24 over the root of 41. And this is minus 6. And a better form we could write this in is x of t is equal to 12 over the root of 41. T minus 2 minus 6. We need to find y as well now. So you have 2 negative 2, and you have 2 plus the root of 41, 13. So my is equal to 13 minus negative 2. And you're going to have this divided by 2 plus the root of 41 minus 2, and that's equal to 15 over the root of 41. So if you use point slope, you have y minus negative 2 is equal to 15 over the root of 41, t minus 2, y plus 2 is equal to 15 over the root of 41, t minus 2. Subtracting 2 from both sides, you're going to have y is equal to 15 over the root of 41, t minus 2, minus 2. So this is just 15 over 41, t minus 2, minus 2. And these are our equations. So we can check these by checking when t is equal to 2. So we get the same points. And we can also calculate what our elapsed time is. And at our speed 3 units per second, our distance is equal to 3 root 41, and that matches what our distance formula says.